two examples here. So we left off example 5. Okay, so that would be 10x plus 17 minus a group of x minus 9 all over 2, oh dear, is equal to 3x plus 1. All right. Now, this one is kind of like a little different, almost special, because it doesn't follow the exact same steps that we had before, like distribute. Okay. Now, in this case, we got this ugly fraction. Let's get rid of that fraction first. Now, remember how I said all over. Over simply means division. So in order to remove that division, I want to do the inverse operation, which is multiplication. So I'm going to put a 2 here. Whatever I do to one side, I do to the other. Now 2 over 2, that reduces to 1. Okay, so let's go ahead and rewrite. Now it isn't so bad. We have 10x plus 17 minus a group of x minus 9 is equal to 2 groups of 3x plus 1. Now we can start with our first step of distribution. Just like before, I said I subtracted a group, so let's distribute -1. Well, that would make that negative x, and a negative times a negative makes a positive. Well, I see some more distribution because I see parentheses. Let's go ahead and distribute my 2 to my 3x, giving me 6x plus 2. And I'm just going to bring everything else down. 10x plus 17, and then equals. All right, now we can combine our like terms. Oh, I forgot that was already in red. Sorry, I used the wrong color here. Okay, so let's start with the left side. I definitely see some like terms, a whole bunch of different like terms. The first one I identify as 10x and -x. Now, whenever you have like terms that are on the same side, you are combining. And remember, we said combining simply means adding them. So 10x minus 1x is simply 9x. I also see that I have some constants, so I'm going to put them in a box. I have 17 and positive 9. So again, we're going to combine them, and that should give me a positive 26. All right, now let's take a look on this side. 6x plus 2. I don't see any like terms, so I'm just going to bring those bad boys down. Okay, after you combine like terms, it says move variables to one side using the inverse operations. Okay, well, this is already all inked up, so how about I go ahead and do it on this side. I have a positive 6x. That means I'm going to eliminate it using the inverse operation of subtracting 6x, and that makes a big fat 0. Okay, I have 3x plus 26 is equal to 2. Love it. Next, we're going to solve, so that means removing the constant closest to my variable using inverse operations. So let's subtract 2x, or 26, sorry. That eliminates, leaving me with 3x is equal to negative 24. Yes. And lastly, I get to remove my coefficient. X is equal to negative 8. Last example, example 6, you'll notice has a lot of different variables. A plus B all over C is equal to 5. Now this is called a literal equation. And this was my goal to get to some time ago, but we're here now. It's whenever you have multiple variables and I want you to solve for just one of them. So even though it says A plus B all over C equals 5, I only want to solve for B. So let's go ahead and begin. This one's really similar to what we had done earlier. So I don't like having this fraction here. So let's go ahead and let's take care of the over C. Remember, over means division. So that means I want to multiply both sides by C. Because C over C reduces to 1. Okay, so now that leaves me with A plus B is equal to 5C. Okay, so remember, B, and I'll go ahead and bold my B. B is what I want to get alone. So B has A attached to it. Now, if you think of this as our commutative property, I could have even written B plus A. A plus B is the same as B plus A. I know you guys like things to look a certain way, so let's see if this helps out. So right now, B has A adding on to it. So my inverse operation to remove that would be subtracting A. Because A minus A eliminates. Now notice, I didn't put my A directly below my C. Well, are they like terms? C and A? No, we said to be a like term, you have to have the same variable raised to the same exponent. So I'm just going to bring everything straight down. Is B alone? Yeah, that means I have solved for B. And this is how we're going to start getting into solving for our averages. See you guys in class.